Hello and welcome to Advances in Emergent Needs in Paleogeoscience Cyber Infrastructure, a webinar series organized by C4P. C4P, Collaboration and Cyber Infrastructure for Paleogeosciences, is an EarthCube research coordination network supported by the National Science Foundation. I'm Leslie Shee and I'll be the moderator today. In today's talk, we have two presentations, each 20 minutes with roughly 10 minutes for questions. We'll want to keep this to an hour, so I'll be fairly strict about enforcing time limits, and we'll give each speaker a 3-minute warning. If you have questions, please send them through the WebEx chat window, and I'll read them aloud after the presentation. You can send in a question at any time. All presentations and follow-up discussion will be publicly archived on the EarthCube website and at the C4P YouTube channel at youtube.com/Cyber4Paleo. Our first speaker today is Chris Jenkins from University of Colorado, and he'll be speaking about the upcoming C4P workshop, Computing with Geologic Time. Our second speaker is Pascal Hitzler from Wright State University, who will be telling us about Ontology Design Patterns for data repository integration. We'll begin with Chris Jenkins. I'm going to pass you the screen. Okay, so you can begin when ready.
All right, thanks, Leslie. So, good afternoon, everybody. I have no idea how many of you are out there because this is an internet mini lecture. So the topic that I wanted to talk on today is the agenda for the forthcoming workshop number 2 in the C4P program. And that workshop is focused on all the computing issues that are concerned with geological time. Computing with geological time.
Just checking that you have clicked OK on the pop-up.
No, I didn't.
Yep, we have it now. Thanks.
Okay, so good afternoon, everybody. I have no idea how many of you are out there because it's an internet mini lecture. The topic this afternoon is basically the agenda for the forthcoming workshop number 2 in the C4P series, and it concerns computing with geological time. So all the issues that we face when we try to deal with geological time data and models in computing systems. There are lots of issues actually, and this has been a little bit of a sleeper problem in the geologic data sets. So let's just have a look at some of the issues and the categories of issues for the forthcoming workshop. So through the workshop, we will be able to showcase numbers of different software, portals, and efforts at data integration. This will just happen throughout the workshop, and it can be on a per interest basis. But the sessions are organized thematically, and I'm going to just go through them all very quickly and then highlight some of them with extra detail. So the first one that struck us is the problem of aggregating or integrating or collecting together geological time data. And of course, we're not just talking about geological time data, we're talking also of all the geological, biological, and ecological parameters that go with it, because we really want to get the Earth history story, not just a series of geologic time numbers. So the big problem here that seems to be facing us is how do we get access to great swags of geological time data and to be able to put it into computing systems. And the awful truth now that we're realizing is the geologic time data is very, very dispersed. It's very heterogeneous. It's poorly indexed. And really, we have quite a big problem here. So the workshop will look at the issue of maybe using sample numbers, IGSN, to get some systematic approach to this. We'll also scan around to see where the age models are hanging out, what sort of databases they're in, what formats. And so the workshop will probably be quite hands-on with this. We'll be going onto the internet and seeing what we can find. Okay, so the second issue then is visualization, and this is the eye candy side of the field. Visualizations are really important, and actually the people dealing with geological time have been good at making visualizations. It's an area that's really sparks the imagination, and so visualizations have been well designed and published. But the question is, how can we generate them more efficiently and quickly off data? So we have some ideas for this, and the workshop will throw those ideas around and maybe test a couple of them. The third issue is data relationships. And when you make relationships between data items, that's when you tend to find where the problems are. So operations like correlation or placing things in order, which I call seriation, that's when you really come up against some quite difficult little problems in the geologic time data sets. So what we want to do is to basically bring the time data and all the associated parameters into a single framework of time. And you know, there are many different suggestions for doing this, but we want to find out whether there's a way through the maze, and we may want to discover some easier ways of doing it. So this is the issue of connecting the data. A fourth issue is harmonizing across the parameters. So a very obvious example of this problem is that we have geochronological absolute ages, which might be derived from isotopic measurements. And then we also have the biostratigraphic data, which is in terms of word-based data. So there are calibrations between the two, you know, the international timescale. But the thing is that we need to look at how those parameters relate to each other in the two or more systems. And this will be in the workshop. So the fifth issue is legacy data resources, and how can we grab hold of them and apply them in research? Maybe lift the pace and the efficiency of the research. So we'll be looking at how to scrape data from web pages and such. The sixth is data relate. Oh, I'm sorry. So that's dealt with. The sixth is realizing and representing uncertainties. Uncertainties are treated as a second-order issue by many studies, but I think that if our products are going to be used, for instance, for decision-making, then we really have a duty to put uncertainties on. So the question is, you know, if we have a gap in data in a drill core, how do we interpolate over that gap, right? What's the best way to do it? And then how can we quantify the performance of that interpolation in terms of accuracy? And then there's another tricky little problem too, and that is the Sadler effect, where rates of change are on a logarithmic scale according to the footprint of your time measurement, the temporal footprint, how long a period of time taking the measurement over. So uncertainty is an interesting issue, and the workshop will certainly be on to it. All right, so now let's have a look at an example of one of those issues. And the first is collecting and aggregating the geological time data. So many people believe that a computational big picture of geology in the continents and on the ocean, in the oceans, that a big picture like that is really achievable, that we're on the brink of being able to do it. And some projects are steadily, step by step, creeping up on that goal. But the awful or awkward truth really is that geologic time information and the associated parameters are badly integrated. People have not given it much attention. So I think that personally, I think although that goal is achievable, it's going to take really a lot of work. So the workshop planning committee came up with this slogan that all archived data should have some age dating information attached. No matter how broad or how preliminary, it needs to be attached and it needs to be flagged with what type of age dating it is, right? So that we can judge it against future efforts, maybe laboratory post-proofs efforts. So this is one thing that we want to test with the workshop crowd, and we'll see what their response is and how we might be able to do it practically. When I know from my point of view in the ocean, we go on a cruise and we might attach a preliminary age date, say based on borans, to a piece of sediment. But then that piece of sediment will be subsampled and taken off to laboratories, maybe in a different country, and then they will do some sort of chemical dating. The problem at the moment is that those revised datings often aren't attached to the original records, and so they're just floating out there, and this is a challenge for integration. The workshop will be asked what is a suitable course of action to remedy this. All right, so age data is often carried by pieces of data items that we call age models. And this slide that we're showing now shows two presentations of age models, one from the German Pangea database, which is very fine and has age models for many, many cores around the world, many different expeditions. You can see the type of data presentation there, it's really data. But then there's another presentation which comes from the Kronos and GeoMap teams, where it's much more visual and it's presented sort of behind the scenes as an RDF or a Commodore image file. So again, we have the problem of different data formats, even perhaps different parameter concepts between the age models. All right, so here's another issue for the workshop, visualization. And the question here really is, should some work be put into standardizing the link between data documents and visuals? And there's a very interesting application that's been on the web for quite a while now, D3. Basically, it recognizes the form of the data in the documents, and then you can bring it into a visualization, a number of visualizations quite efficiently. So the slide I'm showing now just underlines the point that actually geologic time data is quite visual, right? You can develop all sorts of very appealing, practical, and effective visualizations with geologic time data. This particular one comes from the ocean drilling. And here's another one showing the facies and the what would you say, the episodic nature of deposition, in this case from an experimental setup. But you can see that deposition is actually episodic or in bursts very quickly from this graphic. Okay, uncertainty, back to give a little bit more detail on this. One suggestion is that the workshop should have a pens up, heads down sort of issue to perform an actual error analysis, an error budget on classical lines to see just what is involved in getting quantitative estimates of uncertainty. All right, now I mentioned the Sadler effect, the logarithmic effect by time footprint. And here are two graphics. The one on the left concerns erosion rates in the southwest of the US. And those erosion rates differ according to how long a period you measure them over. The longer the period, the lower the rates. And so, yeah. And the same with deposition. Here is some data from quite a while ago. You can tell from the form of the visual. But again, the longer the period, the lower the deposition rate. And since I work in a modeling group, I've been wondering whether numerical models of erosion and deposition are actually taking this into account. I have an uneasy feeling that numerical models are not taking this logarithmic effect and the rarity of big events into account. Okay, so that's all I would like to show today, and what I would like to ask you to do is to have a look at the C4P Workshop 2 materials that are under the EarthCube site. And if you're interested in the workshop, or if you're already enrolled, contact us with any questions, and then maybe we'll be able to fold in your issues as well into the workshop agenda. Okay, thank you very much. Have a good afternoon.
Chris, thanks for that presentation. So we have a couple of questions here about the workshop. The first one is, you mentioned a pretty long list of issues that the workshop is going to address. Do you see any of them as priorities for this time, or do you really want to address all of them?
Well, we'd like to address all of them down to some level, right? But I think the priority one is how to collect, aggregate, and integrate more geological time data. Because, you know, people are really feeling that we can make integrated systems that describe the Earth as a whole. But we need to do some wrangling with the data first. And I think this is really the almost practical issue. Yeah.
Okay, the second question is, there will be a limited number of participants at the workshop. Have you thought about allowing others who aren't able to be there in person to contribute during or after the workshop?
Yep, this is becoming more and more common with workshops. So we'll be having a facility for people to take part virtually with it. And, you know, I've seen a couple of these over time, and they work better or worse, depending on the case. The difficult part is allowing the virtual participants to really take part with questions and suggestions at the moment that the issue is hot in the meeting, right? And so we're really wondering how to do this. It may actually be possible or better to do it through sort of a mobile phone thing to, or Twitter thing, directly to the convener of the session, right? So we're giving this some thought, and if people out there have some suggestions, we're really open to adopt them.
Okay, great. We do have that hashtag. I believe it is EarthCube C4P. I'll check on that and post it up on the workshop site so people can participate that way.
Very good. Yep.
And we have one more question here. After the decisions or discussions are had at the workshop, how do you plan to communicate these to the rest of the community? Yeah,
this is something for the workshop to decide, partly, but we certainly will be producing a document from it, right, which will be a record, minutes, if you like, of the workshop. Whether we go beyond that is really up to the workshop, because it'll involve extra effort. But you know, I'm really on side with video and movies as a medium for communicating. So I'm hoping that we can do something that goes beyond just the document. We'll have to see what people decide in the workshop.
All right, great. Those are all the questions we have at this time, but remember, you can always type a question into the chat at any time. Thank you again, Chris. So we'll move on to the second speaker.
Okay.
Okay, Pascal, you should see a pop-up window, and our second speaker is Pascal Hitzler from Wright State University, talking about Ontology Design Patterns for Data Repository Integration. Okay, go ahead.
Thank you. I just tried to switch on my camera, but I think that's kind of pointless because I have light in the background. So let me switch that off. Excuse me. Okay, thank you very much. I happened to be at the last workshop, and that was actually a very great experience for me already. I'm a computer scientist. I'm a semantic web person, if you want to say, put it like that. To be a little bit more precise, things I specialize in is knowledge modeling and doing something intelligent with the knowledge which you might have modeled. I'm involved in EarthCube, primarily right now as one of the PIs of, well, a project, a Geolink project, an EarthCube project which is just ending now this month, and then the follow-up project which is starting on the 1st of September. The project is called Geolink, and I'll come to that in a minute. What we do there on a very high level is we're looking at the integration of data repositories in the ocean sciences and a little bit beyond also in the follow-up project. So I'll come to that. And when I was at the first RCN, C4P RCN workshop, I learned a lot about the topics and some of the topics and the concerns of the researchers I met there. Of course, I'm still almost blank on the paleogeosciences. So for me, this is a learning experience. I was, and I think I'm also still almost blank on ocean sciences, although I'm collaborating with people on ontology repositories there. And I'm immensely enjoying the learning curve, I have to say. And it's also just a great experience to work between computer scientists and domain scientists, try to capture the knowledge and the experiences there, get them into formal models, and then do something useful with it. So this is what I'm doing, what I'm interested in. And I'm giving this talk, well, essentially co-authored together with Michelle Cheatham, who's also in the same lab as I am at Wright State University, and Christoph Janowicz from Santa Barbara. Both of, somebody has noise in the background, so. Both of whom are also involved in the Geolink project, which I already mentioned, and one of us will also be at the upcoming workshop. I believe we're not quite sure who will manage. So, what do I want to tell you about? You all know EarthCube, of course. I mean, this is why we're here. But let's just take this as a starting point for where we want to go. The declared project, one of the declared projects, is to develop a knowledge environment for the geosciences. So it's about integrating data management, integrating infrastructures, and to create a well-connected and facile environment for sharing data and knowledge in an open, transparent, inclusive manner. So these are very, very, very big goals. One of the things I noticed when I got involved in this in the very beginning, without really knowing much about the Earth science, that just from this general description, the problems you have to deal with here, like information integration, probability, conceptual modeling, data modeling, and comparison, and so on, seem to be problems which are key topics being studied in a research area called Semantic Web, where I happen to be from. So this is why I find EarthCube so exciting. Because it's essentially something I've been involved in for quite a long time already on a kind of conceptual level without having the concrete geo application domain. So now let's go back to EarthCube. Contemplating the goals of EarthCube, there's a couple of things, a couple of requirements, I believe, which the EarthCube architecture, whatever it's going to be in the end, will probably have to satisfy in order to meet the original goals. What we're looking at is we need something which is very modular, which is extensible, which can also be cut down, you can adopt part of what it is, but not all. It should be simple to do a first adoption, but it should also reach out to complex problems. It needs to scale to breadth of topic coverage. And it also needs to respect heterogeneity, meaning individual modeling choices, for example, present in repositories and tools. And doing all this, of course, is tricky. In particular, given requirements like modularity and heterogeneity preservation, etc., it just seems to be not feasible to just say, well, okay, here is one fixed and rigid architecture, and everything needs to fit into this. That is probably not what's going to work for EarthCube at a large scale. And this made us thinking, and our collaborators in the project, and the GeoLink project, the collaborators, the PIs and co-PIs, and some of the participants also are mentioned here on this slide. Kind of what kind of approach on the perspective of knowledge modeling could meet these requirements? How can we make sure that we provide metadata in such a way that we are modular, extensible, respectful of heterogeneity of different modeling choices, etc. And this is what I want to talk with you about next 10 minutes or so. The collaborator on the GeoLink project, and you probably know a couple of the names up here. So Kirsten Leonard, of course, is also the PI of the C4P RCN. There's more people from LDO involved. Robert Arquez, our lead PI, from the Woods Hole Oceanographic Institutions, Peter Wiebe, Cindy Chandler, Lisa Raymond. UCSB is involved, Mark Schildhauer, Christoph Janowicz, and Ocean Leadership, who's also, Doug Phillips is also present in C4P and so on. So just to give you an idea who's there. So what are we going to do in this project from the perspective of the functionality we want to achieve? What we want to achieve, and what kind of our target use case is discovery of information. I'm say an ocean science researcher, and I want to find data pertaining to, say, a certain point of interest, whatever the area around a certain hydrothermal vent, for example. How would I do that? Which repository would I go to? Which repositories would I go to? How do I actually query them all? And do I have to do this all manually? What level of detail can I query them? Well, there should be a way in the information age to simplify this, to make this easier. So our goal on the application side of things is to make a single-stop hub for discovery of data across, well, originally ocean sciences. This is what we did last year, and now extending this towards other application areas, which our partners and also some external partners will provide. And this is the idea. A one-stop hub, a search hub for information. Not necessarily pulling all information into one repository, because that's not working because of all the requirements I mentioned earlier, which we have on EarthCube. We want to respect the individual repositories. We want to respect individual modeling choices. We want to be scalable and extendable. We can't just put all data in our repository. Even technically, that's not very feasible, and from a social engineering perspective, it's impossible. So that should not be the goal here. Rather, you want to have a hub which redirects to other sites, but then you need to have some knowledge, some information accumulated in your hub. And what actually do you need there in order to be able to provide a sufficiently powerful search across different repositories? So the idea which we're pursuing and which we have in place to a certain extent already is depicted on this slide. At the bottom, you see, well, just examples of different repositories: the Rolling Deck repository, Bigfoot Demo, hosted at GUI, AIDA, LTR, Long-Term Ecological Research, etc. And the idea now is that we provide metadata in the sense of so-called ontology design patterns. And I'm going to talk to you in more detail what these are. Think of ontology design patterns as a type of expressive metadata. And if you're familiar with ontologies, then think of them as little ontology snippets which are focused on specific notions. It's not a full-blown ontology, because if you do that, then you lose all the modularity, the easy extensibility, etc., which is required for EarthCube. So we're going to have these design patterns, these ontology design patterns, these little modular ontology snippets, which we call the geolink patterns. And we have mappings from the individual repositories to these patterns. So from these repositories, the patterns can either be populated with data, which will only be partial data from the repositories, or probably not even that. Probably the mappings are only on the schema level, such that the repository might provide a queryable endpoint to which we can then interface from our hub. And then atop of this integration layer, which is the patterns, would be, well, some application-specific modeling catered towards discovery in our case, and then a user interface, a website, and top of that. Okay, so the exciting thing for me as a computer scientist is less the application side of it, meaning the end-user capability we want to provide. Of course, that's the exciting part for the geoscientists and for repositories involved. But for me, it's the question: how do we do that? How do we do that such that we actually meet these requirements, which I mentioned earlier, these extensibility requirements, this preservation of heterogeneity? And here, this idea of the ontology design patterns comes in. So let me go a little bit into this and try to give you a rough idea what we mean with those. So what is an ontology design pattern? They go back about 9-10 years was when the first publication of that came out from a person called from a professor called Aldo Gangemi from Italy. He's now in Paris, I believe. So he was the first to launch that, and it's kind of been growing since that. This is a really nice approach and very useful for certain missions. So what is an ontology design pattern? It is, in his words, a reusable, successful solution to a recurrent modeling problem. So if you do knowledge modeling for different application areas and different contexts, then you notice that certain modeling problems, they just occur over and over and over again from, well, a certain more abstract perspective. They just seem to come up. And there also seem to be central notions which seem to come up in essentially all contexts. You always need to talk about agents if you do ontology modeling, even if you might call them persons and organizations, but essentially they're agents. Very often need to talk about events, about processes, about these kind of things. So why would you model this new each time you do that? That's probably not very helpful. It's more confusing than helpful, because my metadata, my ontology, becomes somebody else's data, and if it's difficult for them to understand, then it's difficult for them to use it, and not necessarily easier than just using the data as it originally is. So patterns provide modular, reusable, replaceable pieces, and that is central. Okay, that is central. So also you can always add another pattern, extend the topic scope. You can probably take a pattern out and replace it with another pattern in a modular, replaceable fashion. This is a key idea here. So by agreeing on reuse of generic patterns, we can have reuse, and at the same time, we can preserve heterogeneity, actually at several levels. First of all, we can cater for heterogeneity by just changing one pattern in the whole set of patterns, because this single pattern did not cater for a specific new application purpose. And we don't have to, dig into changing the whole fabric of the ontology we had originally. But the patterns are laid out such that we have this modularity. But there's also another aspect here which helps with preserving different perspectives. And that is the experience with modeling patterns is that it is possible to really make them rather generic. Meaning it is possible with a little bit of effort and expertise, both domain expertise and modeling expertise, to make these patterns in such a way that they model a notion such that the pattern can be useful for many different points of view on this notion. So we're not capturing only one perspective, but if you do this pattern modeling, you can attempt, and you can do it to a certain extent, to retain versatility in this type of modeling. Let me just do something a little bit more concrete and just look into some modeling. And I'm not an expert on geologic time, of course. I'm also not an expert on temporal modeling at all. But let's still look at a key notion, the notion of age. And let me just give you a few musings, personal musings I have about that. This is completely uninformed by domain experts. So this is really just to get us kind of into the gear of talking about modeling and how to model things in a versatile way. On this first slide, you see what should not be done. And if I show this slide in the appropriate context in front of an audience, I usually get a couple of smiles and laughters, which of course we cannot hear here in the online setting. So a thing has an age, the age is an integer. Of course this doesn't work. On the other hand, well, we all might be surprised how often we might see that if we look at data. So age is of course not an integer. So this is a straightforward way of modeling age in a type of meta model, which is really very restrictive. It doesn't really say much. It's not very helpful. It doesn't do much. So let's stay simplistic. Let's try to do a little step better. And this is still, of course, completely not working, even for simple purposes. Here you would say, well, age is not an integer, but it's an integer with a unit. That's already a little bit better. Right? It's a little bit better, but it falls far short of what I already learned of, well, requirements on modeling the age of something. Let's try to just kind of scrap this, and let's try to take a little bit of more foundational perspective, not just hack something, but think about age. Well, first of all, it's difficult to model the age of a thing because in all realistic settings, I probably never really have the age of a thing, of a sample or whatever. I don't have the age. I only have a reported age. Somebody reported an age. And the somebody now becomes important. So we don't only talk about the age, but we also talk about who actually reported it or what reported it. Was it a document? Was it a person? Whatever. And one of the perspectives we now take in this pattern modeling, and this again relates to modularization, is we can do it one step at a time. So if we say this is a key observation, which you might or might not agree to, as I said, this is just very ad hoc. So I made this up on the spot. We say this makes sense, then we can say a thing has a reported age, which you notice the blob is empty. We're not quite sure what class that would be, but it's a trick called, some people call it reification, or an empty node in RDF. Don't worry about that. It's a complex concept. We could also say it's a ternary relation, a relation which actually relates three things. In this case, a thing about which, the age of which we're interested, a referent, which is whatever reported the age, could be a document, for example, could be a repository. And then we actually have an age description, which is the reported age. And I made those in kind of bluish color, those two, because I want to indicate with this already that these are complex notions. Referent itself is a complex notion. It's not clear what it is. So it would need additional thinking what it is, but let's not do that right now. Let's look at age description. Again, very naively thinking, of course, because I'm naive with this topic. I personally am naive with this topic. So now we can dig a bit deeper and talk about age description. I could think of different ways of describing an age, and some of them were mentioned by Chris in his introductory slides. One thing might be that you indeed talk about a number with a unit. We'll come to that in a bit. But it might also be just naming a period, Jurassic or Renaissance for all matters. So you could say that's a period, for example. I would call it a period. Renaissance is a period. Now I'm actually doing something not so straightforward here, because I'm not just saying, well, has a period, and then I'm plugging in, say, a string which says Jurassic or Renaissance. But I'm saying, well, period is probably in itself, again, a complex notion. So it's probably a pattern in itself. I would think it is a pattern in itself. So if I think of, I can't say much about Jurassic. I understand Renaissance a little bit better. So for example, Renaissance has something interesting, namely, it did not occur in all places at the same time. It occurred in a different century in Italy than in France, for example. So it's a rather complex notion. So we may want to cater for that by just saying, well, okay, there may be some more extensive modeling going on, but for right now we can probably agree on one thing: a period has a name which is put down as a string. Okay, and then we have access to our strings, Jurassic or Renaissance. And then we need to do a little bit more modeling on period to the extended level of detail to which we think it is required. Now let's look at another part. How else could we give age? We could also give age, the age description, as a time interval, which, for example, could be modeled or attempted to model like this. So age description could be a time interval. What does a time interval have? It has a starting point. So it starts at something and it ends at something. And now why did I add these additional blank notes here? Because I thought that probably in many contexts a confidence value, which gives you something about the uncertainty, would also be important. So it's not only that an age description could be a possible time interval, but it's a starting point with a confidence attached to it. It's an end point with a confidence attached to it. And then, of course, some temporal value for which we could, for example, look at reusing the time ontology, which is a W3C member submission, which was made a couple of years ago. So it's a little time ontology, which has a lot of key notions regarding kind of how to put time into ontologies. And now you notice already that modeling here can become relatively complex, of course, but at the same time, it might probably also become clear why this might make sense to look at a meta model, or here an ontology design pattern, which has a more complex structure, because yes, we're talking about complex things. A period is not just, say, a controlled vocabulary piece. A time interval is not just 2 points in time, but we may want to give a confidence as well. So we may want to have a little bit more complicated modeling structure here. To what extent one wants to really do this, to what level of detail, that is, of course, up to what do we want to achieve in the end. Which details do we want to model, which details do we not want to model? But one thing which we can, at least in principle, achieve here is bridging of heterogeneity. Just think of one source which gives the age of, say, a sample by giving a period, and another source which gives the age as a time interval. Now, in this model, we would be able to accommodate both, but we would still have a common model, and this common model could be used for integration. For example, what we do in GeoLink, for querying across different repositories. So this is one of the ideas here. Let me just, because this was just something I made up ad hoc, let me just very, very quickly run you through one of the things we did in our project, not in GeoLink, in the previous project called OceanLink. One of the key notions we modeled there for the repository integration was the notion of cruise, and that actually became a little bit a little bit involved because it was such a central notion. So we had to look at a lot of things, not only about vessels, but also about the trajectory of a cruise. Trajectory itself actually happened to be available as an ontology design pattern which had been modeled previously, so we could reuse that. Also, a cruise, if you think about it from a conceptual perspective, is really a type of event. Now, event, the notion of event has been modeled quite a bit in the ontology world. So again, we could just borrow from their experiences and make a specialized pattern relating to cruises. What we borrowed from the trajectory pattern is mentioned here, and I do not want to go into details here because you're probably not that interested in trajectories and in oceanographic cruises. but wanting to just show you a few pictures. The 4 pictures you've now seen together essentially form the pattern, which should be enough for integrating repository data on oceanographic tools. And it's always fun actually doing this modeling together with friends. I really enjoy that a lot. So here's another perspective you can have on patterns, and this almost brings me to the close. You can also think of these ontology design patterns as a type of interchange format for data. If you make these patterns very generic, such that they can faithfully accommodate data from very different sources, then of course, in principle, you can use them as an interchange format and then kind of pull back from the patterns the information to your repository, although the information might come from a different repository, a different source. This is not something which we have in mind doing right now, but seeing this possibility of doing that is one of the other reasons why, for me, the idea of patterns is so interesting for EarthCube, for the extensibility of EarthCube, because not only can you use it for discovery, you can potentially use it as an interchange format. You could, in principle, also try to attempt use this for building something like tool interoperability, but that needs a little bit more work to deal with service descriptions, for example. But this is also something which is being studied in the Semantic Web world. So, meeting the challenges. I'm kind of running out of time here, so I won't go through this slide in detail. It's the same we've seen earlier, but you've probably got an idea why patterns seem to be helping with the modularity, with the extensibility approach, also with the elasticity. Decide how much you want to share. You can populate the patterns, or you can just model your schema, map your schema to the pattern and say, no, you need to query our repository and website so that we actually get the webhooks and things like that. So this is all I wanted to say at this stage, and I'm very happy if I get questions.
Pascal, thank you very much. We have a couple of questions. So, the first one is, as someone new to ontology design patterns, do you have an example of a success story or a field that has greatly benefited from them?
I mean, probably the interesting thing would be to just wait a few weeks until we have the demonstrator for our ocean science repository integration. Let me put it this way. Using ontology design patterns for this type of integration, this is a new idea. So this hasn't been done before. What ontology design patterns have been used before and are being used for is as building blocks for modeling large ontologies. This was what they were originally conceptualized for, and what has been done. And yes, there's reports on that out there that such ontologies have been used. Now, our kind of step forward, our advance here is to say we're repurposing this whole thing because we see that we can do this heterogeneity bridging. At the same time, since ontology design patterns have been used for say, designing larger ontologies and using these ontologies for information integration, you could say that yes, in principle, we are inheriting all these advantages because there's no reason why we would lose them simply by making a set of ontology design patterns instead of a large ontology. If I had to give an example here, one I was involved in 9 years ago already was essentially before Siri came on the market as part of a rather large inner German project. I think it was probably about $20 million over a couple of years. What we did, we're doing something Siri-like back then. So going from voice recognition to question answering in a specific domain. It was at the occasion of the Soccer World Cup, which happened to be in Germany at that time. And with industry partners and academics. and we did the whole development cycle from voice recognition to the question answering at the end. And in the middle of that were ontologies, which were used for the aggregation of data from all kinds of different purposes. They were not designed using ontology design patterns at that stage, because that was just the time when the idea of ontology design patterns came up. But it could have been just as well. So from that perspective, we're keeping the benefit of using ontologies because we're still within that very same tradition, but we add the additional flexibility and modularity on top of that.
All right, thank you. There's two sort of related questions here. The first one is, what would the C4P workshop in computing with time need to do to collect, what would the workshop need to collect to aid in the construction of a useful ontology design pattern?
I'm not sure it would need to collect. It would probably rather need to connect. So the way in which we do this pattern modeling, and not only in the EarthCube project, but every half year we actually have a so-called vocabulary camp where we do that, about 30 people usually, tailored towards the geosciences. What happens at these meetings is that we usually form groups of, say, 6 to 8 people ideally, who cover the range from modeling, ontology modeling experts, to domain scientists, ideally with different application purposes in mind. And then we sit together and then we say, so what would be a key notion for which you would like to have an ontology design pattern? That's how the trajectory pattern came to pass, for example. And in our experience, is a very, very effective way of doing this type of modeling. So one would need, say, 6 to 8 people coming together and, say, having at least a day or so to just dig into doing these modeling together. And it's not necessary that the domain experts actually have an idea about ontology design patterns. That's why you have the ontology modeling experts in the room.
Okay, and the related question is, if we already have a large collection of semantic assertions, such as thing has age, how would ontology design patterns be extracted or collected from that collection?
So what actually happened in the OceanLink project was that both Bicodemo and R2R, which are the two key repositories we had to integrate, they both had already a meta model, which was essentially an ontology. And it was a rather interesting exercise to sit together with the experts from there who were doing that and running that, and essentially going through this ontology from the perspective of design patterns. Because what happened was ever so often that they said, yeah, right, yes, so I mean, the way you explained that with the design pattern is essentially what we were thinking when we were doing the modeling. We just didn't know how to put that into an ontology, because ontology seemed to be such a monolithic thing. So it is very, very close, and particularly if you already have ontologies. It's just that in an ontology, if you think of an ontology as a monolithic piece, which is made, and an ontology should be made for a specific application purpose, then in ontology you will necessarily make decisions, so-called ontological commitments, which will work for this single purpose, but not necessarily for other purposes. So this is the stuff you have to strip out. You have to strip out, reorganize, clean up a bit, but you can reuse that stuff. Of course you can. So that's not a problem. You need people who actually understand the ontology in that case, of course. Automatically extracting that is something which is a research task which is beyond what can reasonably be done, I believe, currently.
All right, we have one more question here, which is, where can we go to find existing ontology design patterns?
There's our patterns which we did for the OceanLink project should be available from the OceanLink website. You see the URL in front of you right now. Then There is Aldo Dankeny, who got the whole thing started 9 years ago. He is one of the hosts of a website called ontologydesignpatterns.org, where they have a lot of generic patterns, but not necessarily geosciences. Other than that, there is currently not a central repository. So I think the best thing I can offer at this stage is send me an email, and I might be able to provide you with pointers.
Okay, thank you again to both of the presenters. This webinar will be available later, both at the EarthCube website and the C4P YouTube channel. For future webinars, please check the webinar schedule at the earthcube.org site. I just want to make a note that in 2 weeks, the next webinar will be held on a Wednesday, September 10th, instead of the usual day due to scheduling the speakers. So those topics will be DB seabed and automating geochronology workflow. So thanks again for attending, and hope to see you at a future webinar.